Hi once again, and let's look at a few exam type questions on the factory method design pattern. How do you apply the factory method design pattern? So let's look at this question here, which says, consider the UMO class diagram below representing contract types and a list of contracts. Write the class definition of the contract class. You are not required to write any implementation code. So a question like this one isn't really anything to do with factory method. It's just a general question that is saying, can you write a class definition of this class? And when doing such a question, since we are looking at it already, you just need to understand that this here is an abstract class because you can see that's in italics. This is protected because you can see a hash. And this function here is also abstract, which means it's pure virtual. And that is the reason why it's also implemented by the subclasses. So you're simply going to define a normal class, which is called contract, and protected. You include these two data members, and then your constructor and your pure virtual function. And that's it. So you are not doing anything very special in this class. And lastly, but not least, you also need to remember that you're inheriting from Q object, which means your classes are Q objects. Now, the one I'm interested in is 3.2, which says extend the UMO class diagram by adding a contract factory class that implements a factory method design pattern for the concrete contract types. Include the necessary functions in the contract factory UMO class diagram and uses or creates relationships. However, for the remaining classes, you need to only include the class name. Okay, so if you have watched the video on the abstract, on how to on the factory method design pattern, you've seen the UMO class diagram and how it looks like. You do your abstract class, you do your concrete class, then you do your uses and your creates relationships. So in other words, this would look like this. We do have our contract here. And with our contract, we've got our two contracts. In this case, they are my prepaid and my contract. So we've got my prepaid, which is sitting on this side, sorry. And we've got my contract. So the question says, don't worry about including anything else in your existing classes. We only care about the abstract or your application of the factory method design pattern. Now, remember we said for the factory design, for the factory method design pattern, there are two classes involved. The abstract factory class, which defines how your factory looks like, right? So we're going to have, let's say, something called abstract contract factory sitting here. So let's go abstract contract factory sitting here. And in here, we're going to include a function that returns a contract. And we can call this function create contract. So we can go create contract. And inside this function, how do we know which one to return? If not provided, I just go with a Q string. You tell us which one you want. So I'll just go maybe give us the name of the contract, which is a Q string. And this function would return a pointer of type contract, which is a pointer, right? So this then becomes my, my abstract class, right? Let me just put it here. So here's my abstract class, which is sitting here with my function sitting here. And there we go. So obviously there are no data members, so there's nothing in this, there's nothing in this top section here, right? And then inheriting from abstract contract factory is the actual factory. We can call this one contract factory, contract factory. And this is going to have exactly the same function as above, only that the one at the top is abstract, but it will also have a create contract function which takes a Q string exactly as it looks above, which takes a Q string and returns a contract pointer. But this one now is the concrete class, right? So this would be sitting right below it with our, let's just put the function in here. There we go. This is it. And obviously we have no data members in our factory. We just have that one function. And after that, we do our uses. So remember, we've got your uses relationship sitting there. So this would be that guy. And then you can go uses, and then our creates relationships will sit on this side. And then we can say creates. And that is how you apply the factory method design pattern. So if you look at the original diagram that we did in the overview of the factory method design pattern, I think it should be the video right before this one. It's exactly the same diagram. The only twist is that we've changed the names to be contracts. We return a contract, not a product. We've got two classes. Our creates relationships are here. It's association, and that's it. It depends on the convention that you're given for exams, but sometimes you can underline this to prove that this is a pure virtual function, because you cannot really write in italics unless you are typing, then you can make it italics. But if you're writing, it may be difficult to indicate that this is an abstract function. So I've seen that in some exams, they say for abstract functions, just underline it so that we can see that this is also in italics. So that is the convention you use. But basically, that is how you apply the factory method design pattern. So it's very straightforward. Every time you need to apply factory, this is what you simply do. Now, the next question then says, assuming that the user choice for a specific contract type is stored in the variable QString choice, write code that will return the required object using the factory method pattern from question 3.2 above. The choice variable is the only object you may assume exists. Now, if you understand the factory method design pattern, you understand that there are two things that you do. You define your factory and you implement your factory. And in the implementation, that is where you return your instances. And they are saying, assuming that the choice, the decision for which one do you want is being kept in a variable called choice, right? Write the code that will return the required instance using the factory method pattern from question 3.2. So if we have a variable which is a QString called choice, how would you use your factory to give us an instance of a contract? In other words, you have to find a factory here with a function called create contract, which needs the name of the contract that you want, or the choice of the contract that you want. The question is saying, how would you use your factory to return that contract? So in other words, we are saying that we already have a QString called choice somewhere, right? They said assume it exists. Maybe the choice is called my prepaid. But this is not part of your answer. They are simply saying it has been defined. Now, how would you use your factory? Obviously, the first thing you want to do is make an instance of your factory. So we can go, I can use a polymorphic assignment or just a contract factory. Sorry, pardon me. I forgot to put the inheritance that is sitting here. I'm only seeing this now. So here's your inheritance. Sorry about that. So I can make an instance of my factory and then use that instance to return an instance of a contract. So I can say, here's my contract factory. I can call this one F. All I need to do to get an instance of a contract C is to go F dot create contract, and I give it the choice that we have. That is how you would do it. And that's it. Make an instance of your factory and call your factory method, which is the one returning the instance of a contract. Now, here are some variations for doing this, right? You can also create an instance of your factory like this, abstract contract factory. Let's call this F, because new this contract factory, and then we can go, contract C equals new equals F dot create contract. Right. That is also another way. If in this case I have both the abstract factory and the concrete factory, I can also do it like this. Or if you want, you can also use a pointer of type contract factory in the second example or in the second variation. So here this can be a contract factory instance that is also allowed. But the main idea is that you need to create an instance of your factory and then use your factory method to return the instance. Right. That is the last thing you need to understand. So basically with factory method, there are three things you need to understand. Number one, how do I apply the UML class diagram? How do I define the factory if I need to? How do I implement the factory? And lastly, how do I then use my factory to return an instance? So that's actually four things. But when it comes to the coding side, three things, okay? Defining your factory, implementing your factory, and how to use your factory to return an instance. Okay, let's look at another example on factory method. This question was not really on factory method. It was something now to do with reflection. So I won't look at this question at the moment. But let's look at this example here, which is very interesting. And this one says, the following class hierarchy is designed to generate input fields for specific data types for a GUI application in a generic way. The Q-variant class is used in the class hierarchy to handle different data types generically. And here your class is for an input field, which is abstract, or the functions here are also abstract. And inheriting from here, you have three classes: string input field, double input field, and date input field. Apply the factory method design pattern in such a way that objects of concrete classes in the input field class hierarchy can be created based on the Q variant. That is very critical. Based on the Q variant that is passed to the factory method. Present your design using a UML class diagram. Note that you're expected to include relevant functions in the class diagram for the new classes in your solution. There's no need to include the client solution in your solution. So why did I underline this part? In the previous example, the question was, how do we know which contract? And we said, well, we use a Q string to decide. And as you saw here. Now, in this question, they are saying, you don't decide using a Q string. You're going to decide which one to return based on the Q variant that is given to your factory method, which means in this example, your factory method is being given a Q variant, not a Q string. Okay? Your factory method is being given a Q variant, not a Q string. And based on that Q variant, you then decide whether you want this one, or this one. We are not implementing here. We are just drawing the diagram. And it looks exactly the same, right? We have here an input field, which is abstract. And inheriting from our input field, we've got string date, string double, and date. So we've got string input field here, right? These are our three classes. And obviously for the existing ones, we don't really have to include all the functions. But what's important now is the fact that we need our abstract class and our concrete factory, right? So I can then have abstract input field factory here. So I can go abstract input factory. I just want to shorten it. And in here, I'm going to have a function, create input field, for instance, or just create field, right? And this function takes a Q variant V, which is a Q variant, and it returns an input field, right? There. That's my factory, right? And I can just do this here. And inheriting from here, we've got our input factory. So I can go here, input field factory, whatever you want to call it, or input factory. It doesn't really matter what you call it. We just start from here. Input factory. And in here, we've got a function, create. Now, exactly as it is in the abstract class, create input field. And we've got a Q variant, which we are using to decide which one to return. Q variant, and it returns an input field like that. So this becomes my concrete factory like that. So here's my factory, and inside my factory, I have my factory method. And what we do next, we've got our uses, relationships, and we've got our creates relationships. And when I've done this, I have applied the factory method design pattern. Okay. Then the next part then says, the factory method design pattern decouples the client from the concrete subclasses of the class hierarchy. Explain two benefits of this decoupling between the client and the concrete subclasses of the class hierarchy. So now this is now a question about the benefit of using these design patterns, and there are many reasons you can give here. You can talk about code reuse, and you can talk about extensibility. You can talk about maintainability as well. It makes it easier to maintain your code because of the separation of responsibilities. Code reuse, you can reuse your factory in any other client that wants an input field. Extensibility makes it easier to extend your application because you can now include more input fields, and you won't need to touch your client. You just have to go and edit your factory to return more of those instances. So adding more instances won't affect your client. So now this is more like a general question on the benefits of using the factory method design pattern. And here's another example. Along with flights and passengers, a database of available aircraft is also needed. The following aircraft YAML class diagram and aircraft database class have been proposed. The QMap in the aircraft database maps an aircraft registration number to the aircraft instance for that particular registration. The sequence numbers provide a unique number for each aircraft, so that's the aircraft stuff that's going on there. Now the question says 3.3. The design team decided that a factory method design pattern should be used to move the responsibility of creating aircraft instances to a separate class, create aircraft. Assuming that the class definition for this class exists, write the code for the function that will implement the factory method pattern as it would appear in the create aircraft class implementation file. You may assume that only two types of aircraft will be involved, where the class names are given in brackets and are derived from aircraft. Here's the aircraft, and this one Airbus. So they are saying we've got two types of aircrafts. Now, remember factory method, 4 things you can do. Apply YAML class diagram, define the factory class, implement the factory, or show us how to get the instance using your factory. Of those 4 things, what is this question asking for? Write the code as it would appear in the implementation file. They want the implementation of your factory, in this case, which is called create aircraft. So if we had to apply factory, we were going to have a function here made called create aircraft. In this case, maybe because the class is also called create aircraft, I would avoid calling this the function create aircraft as well, because then it would be the constructor. So since the class is called create aircraft, I can call this create or get aircraft, whatever. It doesn't matter what you call the function. Let's be honest, it doesn't matter what you call the function. I'm going to call this one get aircraft, right? Get aircraft, which means in my create factory, I'm going to have a function which requires a Q string, and so that I can decide on which aircraft to return, and this returns my aircraft pointer, right? and this would be my create aircraft class. And if this one here is the concrete one, it means what did I do here? I don't want to do that. I wanted to, okay, so if this is my concrete class, it would be below. So let me call this one abstract. So assuming this is my concrete, let me make this one the abstract, right? Let's just go abstract, create aircraft. You have your inheritance here, then you've got your create aircraft sitting here. This is not required by the question. I'm just doing this to make it easier to understand. Oh, sorry. It's not really required by the question. This would be your concrete one. And in here, you'd have your get aircraft function, which takes a Q string and returns an aircraft, right? And obviously, you would apply factory by just going, it uses that. And then you would go creates, right? Just it's a bit messy, but I think you get the idea. So these are your creates and uses relationships that are sitting at the bottom here, exactly as before, and so on and so on. The question is saying, show us the implementation of this class, which means what matters here is how you implement the abstract method, which is this function, right? So all you want to do here, you've got two instances, the 738 and the 8388. So in your implementation, all you want to do is, well, I am returning an aircraft pointer. Your class is called create aircraft. Your function is called get aircraft. I could call it create aircraft, but I mean, it would look like a pointer, I mean, like a constructor, so I won't do that. It gets a Q string, the name, and in here, it's a simple if statement. If the name is equal to 7A73 something something, whatever, what is it? It's B738, B738, and just return new B738. Now, this is the name of the class. Otherwise, if your n is equal to A388, then just return a new instance of type A388, new A388. Otherwise, just return now, like that. That is how you would do your implementation file. So you can say that abstract method design, abstract factory method design pattern is very straightforward to apply. It's all about the function that returns an instance. The only question that I found tricky out of all these questions is the one that used the Q variant. Fortunately, they did not ask you how to implement the function. They just wanted you to know that it's based on the Q variant. A Q variant is a function to determine if that Q variant is a string, a double, or a date. So in the implementation, that is what you then use. And in most cases, if it gets to that level, they give you the function in the exam so that you can use it, right? But in the implementation for this question, in your factory method, you would then use an if statement that says if v dot date, then cast your date. If v dot string, if v dot type is equal to date, then this one. If v dot type is double, then this one. If v dot type is input field, then is string, then return this one. So that is the kind of an if statement you would then end up in here using the type function of Q variant, but it wasn't required. And in most cases, if it gets there, they tell you about those functions so that you can then use them. Otherwise, that's it about factory method design pattern. You must just practice more questions. It's a very straightforward design pattern. I find it one of the easiest. How to apply the HEMO class diagram, how to define your factory, and how to implement your factory. Finally, how to use your factory to get an instance. All right, I'll see you in the next video. Cheers.